Hello everyone, welcome to today's lecture. So did you understand yesterday's lecture? Hope you have understood the topic very well. Now the next is concentration of solution. Now by the term concentrated means what? Concentrated means the concentration of a particular compound is more in it. Okay, a solution is made up of a solute and a solvent. This you know. Okay, solution is equal to solute plus solvent. So a solution in which the solute concentration is more, it is said to be a concentrated solution, and a solution in which the concentration of solute is less, it is said to be a dilute solution. You may see the definition on the second last paragraph of page number 62. You may underline the points. The proportion of a solute in a solution is called the concentration of the solute in the solution. When the concentration of a solute in its solution is high, it is a concentrated solution, while the solution is called a dilute solution when the concentration of the solute is low. Okay, you may mark that. Now, in the next paragraph, what they have given, I have written it here. So, concentration of solution is the proportion of solute in a solution. Now, while calculating the concentration of solute in a solution, there are two units which are used. Okay, two units. What are the two units? The first unit is gram per liter. Gram per liter. How will you calculate it? The equation is mass in gram upon volume in liters. Mass in gram upon volume in liters. You may write this on that page itself in your textbook. So gram per liter is the first equation, mass in gram upon volume in liters. The next unit is molarity. Okay, what is the molarity of the solution? How will you calculate the molarity of the solution? Molarity is equal to number of moles upon volume in liters. Okay, number of moles upon volume in liters. Now how will you define it? You may see in the next paragraph. The first unit is the mass of solute in grams dissolved in 1 liter of the solution. The second unit is the number of moles of the solute dissolved in 1 liter of the solution. Okay, and it is represented by putting brackets on both sides. So what are the two units? The two units are grams per liters and molarity. How will you calculate gram per liter? It is mass in gram upon volume in liters, and molarity, number of moles upon volume in liters. Okay. Now the next, they have given a table on page number 63. Complete the following table of the concentration of various aqueous solutions. Okay, so you have to calculate the concentration of various aqueous solutions with the help of these two equations. Now what all has been given? They have given the solute, name of the solute, molecular formula, molecular mass, that is grams. How many grams? That is this mass in grams. E, that is number of moles. Okay, number of moles. Volume of the solution in liters. Okay. G, you have to calculate gram per liter, and molarity. You have to calculate the unit on both units, the value in both the units. Okay. First one is sodium chloride. They have given the values of every value of sodium chloride. Molecular formula, the molecular formula is NaCl. Molecular mass is 58.5. This we had calculated in chapter 4. If you don't remember, you go through what is molecular weight, how to calculate molecular weight from chapter 4. It is a very important question. Okay. Now the next is number of moles, grams. Mass in grams, they have given it as 117 grams. Number of moles. How will you calculate the number of moles? This also we had studied in chapter 4. Number of moles is equal to mass in grams upon molecular weight. That means 117 upon 58.5 will give you 2. So 2 moles. Volume in liter is 2 liter. First you have to calculate grams per liter. How many grams it is? 117 grams. Okay, 117 grams in 2 liters. 117 grams in 2 liters. If you reduce it, it will come to 58.5 grams per liter. It is actually 117 upon 2 liters. Okay, it will give you 58.5 grams per liter. How will you calculate the molarity? The molarity is number of moles upon volumes in liters. How many number of moles? 2. How many liters? 2. So 2 upon 2 will give you 1 molar. Okay. Now the next is hydrochloric acid. The molecular formula HCl. The molecular weight is 36.5. Okay, hope you remember how to calculate molecular weight. The mass in grams is 3.65. They have given this 3.65. Molecular weight, this is a blank given that we have to write. Number of moles will be the mass in grams upon molecular weight, that is 3.65 upon 36.5, that is equal to 0.1 mole. Volume of the solution they have given as 1 liter. Okay, this is a blank given. Now you have to calculate grams per liter. Grams per liter is 3.65 upon 1. Okay, number of moles, mass in grams upon 1. Mass in grams is 3.65 upon volume in liters is 1. So 3.65 upon 1, that is 3.65 grams per liter. Now molarity is equal to number of moles upon volume in liters. Number of moles is 0.1. Volume in liters is 1. So 0.1 upon 1, that is 0.1 molar. Okay. Now the next is calcium hydroxide. The molecular formula is CaOH twice. The molecular weight is 40. You have to calculate it. Now quantity of the solute, that you have to find out. They have given the number of moles as 1.5. From the number of moles and molecular weight, you can calculate the mass in grams. Why? Because number of moles is equal to mass in grams upon molecular weight. This equation we had learnt in chapter 4. You may revise. So volume of solution, they have given it as 2 liters. Gram per liter, number of grams, how many grams? 60 grams. How many liters? 2 liters. So 60 upon 2, that will be 30 gram per liter. And molarity is equal to number of moles upon volume in liters. Number of moles is 1.5 upon 2, that is equal to 0.75 molar. Generally no questions are asked from this table, but the questions which are in the exercise, they are asked. Basically what they want you to learn from this is this much. Okay, what do you mean by concentration of a solution? The proportion of a solute in a solution. Okay, if the proportion of solute is more, then it is said to be a concentrated solution. If the proportion of solute is less, then it is said to be a dilute solution. There are 2 units to calculate this concentration of a solution. The first unit is gram per liter, which is equal to mass in gram upon volume in liters. And the second equation is molarity. Second unit is molarity, which is calculated by the equation number of moles upon volume in liters. Okay. Now the next is pH of a solution. Okay, we will see the topic. Before that, you may copy this in your notebook. The next topic is pH of a solution. You might have learnt about pH of a solution, heard about pH of a solution. Okay, about pH is 0, pH is 7, pH is 14 or 1, 2, 3. Okay, 7 is taken as neutral, below 7 is taken as acidic, and above 7 is taken as basic. Okay, now what is exactly pH of a solution? It is the concentration of H positive ions or OH minus ions in a solution. Okay, they have given the pH values of some acidic and basic substances in the table on page number 63. It is a very important table. You have to learn the pH of each and every type of solution given. For example, 1 molar HCl, the pH is 0. Gastric juice 1, lemon juice 2.5, vinegar 3, tomato juice 4.1, black coffee 5, acid rain 5.6, urine 6, rain or milk it is 6.5, pure water or sugar solution it is 7, blood 7.4, you may mark it. It is a frequently asked question about milk and blood. Okay. Solution of baking soda, it is 8.5. Toothpaste is 9.5. Milk of magnesia 10.5. Lime water 11. And NaOH solution, it is taken as 14. Okay. Now how these numbers 0, 7 are taken? Okay. So the pH of a solution is the concentration of H positive ions formed during dissociation of the particular acid or base or whatever compound it is, ionic compound. Okay, so for water, when it is dissociated, how many H positive ions? It is 1 into 10 raised to minus 7 moles per liter at 25 degree Celsius. This much of H positive ions are formed. So the pH of water is taken as 7. Okay. So for HCl, it is 1 into 10 raised to 0 moles per liter. So the pH is taken as 0. NaOH, it is 1 into 10 raised to minus 14 moles per liter. Okay, these are the values given in the textbook. Okay, so according to that you may study. You have to just remember. So if these are the objective type questions which could be asked. So concentration of H positive ions formed by dissociation of water is 1 into 10 raised to minus 7 moles per liter. HCl is 1 into 10 raised to 0 moles per liter. NaOH is 1 into 10 raised to minus 14 moles per liter. Okay. So the range of pH value extends from 0 to 14. Even this is an objective type question. So the pH scale ranges from 0 to 14. Okay. Now on page number 64, they have given a can you recall question. So before that, in the first paragraph, you may mark the name of the scientist. In 1909, the Danish scientist Sorensen introduced a convenient new scale of expressing H positive ion concentration, that is the pH scale. Now can you recall question? What are the colors of the following natural and synthetic indicators in acidic and basic solutions? I have drawn the table here. You may draw this table in your textbook and in your notebook. For litmus, in acidic condition it shows red color. In basic condition it shows blue color. This you had studied in your 8th standard. Turmeric, it is yellow in acidic conditions and red in basic conditions. Jamun, it is red in acidic conditions, blue-green in basic conditions. Methyl red, red in acidic conditions and yellow in basic conditions. Phenolphthalein is colorless in acidic conditions and pink in basic conditions. So these are the different type of synthetic indicators which are used. Okay. Now there is a universal indicator which is used. And what is a universal indicator? The universal indicator is a mixture of synthetic indicators in constant proportions, in decided proportions. Okay, that is a universal indicator. So with the help of these indicators, you can tell whether the given solution is acidic or basic. And with the help of universal indicator, you can tell the pH of the solution also. On page number 64, they have given a chart, okay, for pH indicators. From 7, it is neutral. Towards the right, that is 7 to 14, it is basic, and 7 to 0, it is acidic. Now what is the most accurate tool which is used to measure the pH? It is the pH meter. So for today, we studied about concentration of a solution, the 2 units to calculate the concentration of a solution. What is pH of a solution? You have to learn that chart of pH of solutions. Okay, and what are the different colors which are given by different indicators? What is a universal indicator? This much you may read and study. Okay, thank you.